Hello, it's Jim Games here once again and welcome to this new Unreal Engine 5 tutorial. In this video we're going to add a play sound event to our game event code. So you can actually play the sound at world location or relative location to the player or as 2D/UI sound. Also you can select if you want to rotate the sound to player, and you can set the volume, pitch, and volume randomness and pitch randomness. So yeah, let's get started. So what we want to do first, we want to go to the enum folder and we want to create a new enumeration. And let's call this location enum. Okay, let's open it. Here in the location enum, we want to add two new enumerations. Three. And the first one will be called world. The second one will be called relative. And the third one will be 2D/UI. Or you can just leave it, call it 2D or UI, but I will call it like this. Okay? Come on! Like 3 ads in a row. Okay, so let's save. Let's close this. And now what we want to do, we want to go back to the blueprints, and here we want to go to the structures and to the game event. And now we want to create a new structure. And let's call this GE, which stands for game event underscore play sound struct. Okay, let's open it. And here the first variable will be called sound, and it will be the actual sound file. So let's search for a sound cue and object reference like this. The next variable will be called, let's call it type. This will be basically which type of location or like where we will play the sound. So if we will play it in world position or relative, or if we play it in basically as 2D sound. So now let's click on the variable type and let's search for that location enum that we just created. Location enum under here. Okay, so here you can select world, relative, or 2D/UI. Okay, so the third variable will be called location, and that will be the actual location where we play it. So it will be type vector. The fourth one will be called rotate to player, and it will be type boolean. So this will basically just check if you want to make the sound face or like play to the direction of the player. Okay, the next variable will be called volume, and let's add here like this percentage symbol, and this will of course be float. Okay, the next one will also be float, and it will be called pitch. Okay, and two more, they are both also floats, so let's create them. So the second last will be called volume random percentage, so like this. Okay, and the last one will be pitch random and this percentage symbol. Now let's save. Now let's go to the default values. So what we want to do here is let's actually set this rotate to player to true. And the volume, let's set it to be 100 as default. Pitch, let's set it to be 1. And volume random, let's leave it to 0. And also the pitch random, let's leave it to 0. I will explain later what this does. Now we can save, we can close this. And now we can actually go to the game event struct. Okay, here let's go to the structure. And let's add new variable. And let's call this sound. And that will be the GE play sound struct. And let's also make it array like this. So let's actually save all. Let's also save this. I think it already saved before from here, but yeah, just to be sure. Now we can close this. The next thing that we want to do, we want to go to the blueprints and to the interactable, I think, game event. Yeah, let's open the game event blueprint class. So now we have to do some coding when this opens. So we don't need to do anything here or here. So let's go to the event graph. Under the objective, let's actually create a new custom event. Let's leave some space. Let's create it about here, I think, or here. So custom event. And this custom event, let's call it sound. So what we want to do next, we want to get our current event, yeah, like this. Get it, let's split it, and now we have this current event sound here. If you can see it, you have to compile first. So we're doing the same thing as here, but now we're getting the sound. So we want to get from the sound, and we want to check if it is not empty, like this. And let's add a branch, so bn left click. And let's connect it to here. Okay, I will make it look more like this here. So if it's not empty, then what we want to do is we want to get from the current event sound, and we want to for each loop. Let's put it here. Let's double click from here to create this reroute. We'll select it and press Q to align. So if it's not empty, we will run through it. So here we want to promote this array element to a variable like this. And let's call this sound struct. And let's actually create a new category for this. Let's call it event structs like this. And let's also move the objective struct to there. Yeah, I want it to be over the zone struct because that's the right order. And you can move them like this. Okay. So the next thing, what we have to do, we have to create a new function, which will be called play sound. And now let's go back to the event graph, and let's call the play sound after this, after we promote this array element. So basically this struct to the variable. So if it's not empty, we're getting all from here because this is an array, and we're promoting it to a variable, and we are running all the code that it will actually play the sound. And after that, it will run through the whole array. So it will play every sound basically that you set there. Now we can open the play sound. And let's actually compile and save all just to be sure. And now we actually have to create a few functions more. So the next function will be called find. Actually, sorry. Let's create this one first. Get sound volume settings. Okay. And here what we want to do is we want to first get our sound struct. We want to get it and we want to split it. Now we have all these pins here. And now what we want to do is we want to click on this input and we want to actually add an output. And we want to change this variable to be float and we want to call this volume and we want to add another one and this will be called pitch. And now let's make this whole function as pure like this. And now we want to leave a lot of space here. Okay, so yeah, now what we have to do is we want to actually get random float in range. Let's get it to around here. Let's copy and paste, Control C, Control V. Okay. So what we are doing here now, we are getting our volume and now we have these random values here. So what we will do, we'll get this and make this as the maximum value. And if we have, for example, the volume as 100 and we have this random at 50, then we will make it so the minimum value will be the volume minus this, so it will be from 50 to 100. So you will have some randomness on the volume if you use these random values. And here we will have to do some a little bit more, but it's not that like difficult. So first let's get our struct volume, sound struct volume, and let's connect it to the max because it will be the max value. And let's add a reroute. And then we also want to add here another reroute, and we want to minus subtract from it like this. And now we want to get sound struct volume random percentage to here. And let's also add a reroute maybe to here. And I want to actually align these. Okay, so let's connect this to here. So one more time, we're getting the volume percentage and we are subtracting. Sorry, I'm a little bit tired today. So we're subtracting the randomness percentage from it, and that will be the minimum value. And the max value will be just the volume. Then what we have to do here is we will have to divide this whole value by 100, because here on Unreal it will be, the volume will be like a value between 0 and 1. So like this. Okay, it actually doesn't have to be between 0 and 1, but that 1 is basically 100%. So yeah, okay. The next thing here on the pitch, what we have to do is we will have to first get the sound struct pitch, and we will have to subtract from it like this. And let's connect this to the minus. And then we want to get our sound struct pitch random, and we want to divide this by 100 here. And let's actually move it to around here. Now we want to connect this to this subtract node. So if our pitch is 1 and we want to our random percentage is 50, then we're subtracting the 50 by 100, dividing, and we have 0.5, and we are subtracting the 0.5 from it. Okay, that's the minimum value, and the maximum value will be, of course, the soundtrack pitch as it is. So how can we make this look a little bit cleaner? Let's move this a little bit further down. Let's add a reroute, maybe to here. Let's move this to here. And from here, let's connect to the max. Let's double click to add reroutes, maybe like this. And now let's align it with the Q. So we're getting the value, we're subtracting the randomness divided by 100, and that will be the minimum, and the maximum will be the soundtrack pitch. Yeah. And here we can just get it and connect it to the pitch. And let's also add a reroute so it looks nice. Now, compile, save all, and let's create the next function. So the next function will be called find relative location to player. Okay, and here what we have to do is we have to first get our player reference that we actually don't have yet, and we can actually create the variable. So let's create a new variable. Let's call it player ref, and let's change the variable type to player. I don't remember the name. I will actually have to check it. So here, BP player character. Okay, simple as that. So BP player character object reference. And let's make it instance editable and expose on spawn. So now when we compile, save, and we go to the interactable and to the game event and to the event trigger, here where we create the game event, now we right click this and refresh, we have this new player ref node here. Now let's move this maybe to here. Now we can get this as BB player character and connect it to the player ref. Now we will have the variable here. So compile, save, and we can close the event trigger. So play sound. Find relative location. That's the one. So we will have to get our player ref, which we actually want to move to the reference folder like this. So let's get it. And from here we want to get root component. And from the root component, what we want to do is we want to get world location. Then we want to get forward vector like this. Now we also want to get right vector, and then we also want to get up vector. Okay, we will need all of these. So now we have this get world location. We can just get from that, and we want to add to it. Now here, get forward vector. Here we want to multiply, and we can connect this to here. And now let's select our input, and let's create a new input. Let's call this location, and let's change the variable type to vector. Okay, compile, save. Now we can right click and search for a location. It should be under the variables here. It's this one. You can also just get it from there, but I think this is better. Now we want to split this like this. And forward vector. Now we want to get our X and we want to connect it to here. So we want to multiply the forward vector by the location X and add it to the world location. Now let's copy this node. Control C, Control V. And actually I will do one thing here because this annoys me for some reason. I want them to be aligned better. Sorry. So now what we want to do, we want to multiply the right vector by the y value of the location y. And after that, we want to add a new pin here, and we can just add this to there. Then here, we want to copy this variable one more time. Now we want to get from the up vector, and we want to multiply and connect the set location. So we're getting the vector, basically the location in front of our player. Okay, and we're multiplying it by the X location. To the right of the player, multiply with the Y location, and up from the player, multiplied with the Z location. So we're basically getting the relative location of the player. Now we will just have to connect this here and do these nice alignment things that I like to do. So now let's get from our, let's click on our input and let's create an output, and this will be called relative location. So we basically change the world location to relative, or like this is not basically world location, but the yeah, you understand. So let's move it to here, connect this to here, and make this whole function as pure. And now I noticed one thing. I want to select this and press Q, and now it looks pretty okay. So compile, save, and let's create one more function. This last function will be called find look at rotation to player. Look at rotation to player. So here we want to just get our, we want to just add the location variable here to the inputs. So location, and then we want to get from this, and we want to find look at rotation, this one. Now let's get our player ref again, and from here get world location, and we can get the capsule component. It actually doesn't matter that much. Let's select and press Q, connect to the target. So we're basically just getting our location that we have set to the struct, and then we're getting our player's location, and we're getting the rotation from here to the player. Now let's add an output, and let's call it rotation. And let's just change the type to rotator and make this pure, and move this to here, and we can just connect this to here. Simplest. Compile, save, and let's actually save all, and let's go back to the play sound. So here we want to get our sound struct, and we want to get it, and we want to split it. And from here we want to get our sound struct type, and we want to switch on location enum. Now we have to leave some space here and right click and play sound at location. Let's open it. Let's connect from the world like this. So now we have to get the sound struct again to here maybe and split it. So let's connect the sound struct sound to the sound. Simple as that. And the location, we can just connect to the location. Then from the rotation, we want to select rotator like this. And let's actually add a reroute to here maybe. Let's see if I can, yeah, now it's better. Now we want to check sound struct rotate to player. Let's connect it to here. Let's add a reroute again. So the B will be 0 if we don't rotate to player, and A will be our, let's get from the sound struct location, and we want to find relative, look at, find look at rotation to player. And we will have to move this whole thing a little bit further, like this, and connect this to A. So if this is true, then we will find look at rotation to player. And we can use these same functions later on when we spawn some enemies or jump scares or whatever. So, yep. So to here, what we have to do, we have to get our get sound volume settings. And we already created this, so we can just connect this to the volume multiplier and this to the pitch multiplier. Simple as that. So now compile, save all, and let's copy all these. Control C, go a little bit down here, Control V, like this. Now let's get from the relative, and let's connect here. Let's add some reroutes, maybe to here. And here we will have to change few little things. Actually, almost nothing. So we will just have to get our find relative location to player and put it here and connect this to here and connect this to here. And I will actually have to move this a little bit further down, like this. So, and actually, yeah. So the only difference here is find relative location to player. So we're getting the location from our player's relative space. Okay? So the third and the last one. Here we have to, or we can just right click, play sound 2D. Let's open it. Let's get from the 2D/UI. Let's add a reroute to here, I think. Yeah. And now we can just get the sound struct, and we want to split it. Here we have to just get the sound struct sound, and also the get sound volume settings. Volume to the volume and pitch to the pitch. And we can later on add things here if we want. Yeah, and this actually doesn't matter, and yeah, this doesn't either. So yeah, okay. Compile, save, and let's go to the event graph. Now here on the game event, where we actually call all these things, what we want to do. So we want to add a branch here after the objective thing. Okay, and here we want to check if we can continue. And if we can't, so false, let's call the next event checker. And if we can, let's call the no, not that one, sorry, the sound, not the play sound. Sound, come on. Here, call function sound. So this one here. Okay. And after that, we can copy this and paste it here. So next event checker. Simple as that. And one more thing that I want to do in this video is let's select these objective and sound codes. Let's move them downwards like this. Also this even more. And let's select this objective thing and press C so it creates this comment box. Let's make it better size. And actually, let's make it like this. Let's call this objective. And let's set here some little bit different color like this. Now the sound. Let's call this sound. Let's set this to something. Yeah, something like that. And now we can actually get it a little bit closer. Maybe like here. So yeah, so it's just a little bit cleaner. And let's move this inside the box like that. Okay, let's try if everything works. So compile, save all. Let's go to the level. And here is our first trigger box. Let's click on this. Let's delete the event and let's create a new one. Let's open it. Objective, we don't have to add anything to there. The sound, let's open it. Let's select any sound, maybe this explosion. And let's set the world. Let's actually check what is this location. 900, 900, yeah, 900, 900, something like that. Let's write 900, 900, and let's set the volume 100, pitch to 1. So save, and let's play. Let's see. Okay, it worked. And also, if we unselect to do once, yes. And let's actually quickly try the randomness. So volume random, let's set it to 50. So it should be from 50 to 100 now. Let's actually increase the value. So let's make it 100. So now it should be from 0 to 100. Yes, it is working. Let's also try the pitch. So let's set this to 100 also. Yes, it is also working. So now let's try the relative. Let's set all these locations to 0. Now it should play at the location of the player. Actually, I will set these to 0 so I can hear it better. Yes, and if you want to make the sound play in front of the player, you can use the set the x-axis. So 100 is 100 units in front of the player, y is to the right, so minus is to the left, and z is up and down, basically. And now, if we click 2D, it will just play 2D sound. So yeah, everything is working like it's supposed to work. So yeah, I think that was all for this video. If you like what you saw, please click the like button and subscribe for more. And yeah, hope you have a good day and see you on the next one. Bye.